Hey, it's Dawson Rudebush, and for my Chapter 8 and 9 project, I'll be doing NF3. So the first thing we're going to look at is the electron configuration. So we first find nitrogen on the periodic table, and then we go over to the first noble gas, which is helium. Write down helium, and then you skip the two S's. So you put 2s2, then you go to the two P's and go over 1, 2, 3 to nitrogen, and write down 2p3. To find fluorine, it's basically the exact same way, but instead of going over 1, 2, 3 to nitrogen, you go over 1, 2, 3, 4, 5 to fluorine. So it's F is He2S2p5. The next thing we're going to quickly be looking at is the valence electrons. So first you take nitrogen, and it's in the 5A group. So there's 5 nitrogen valence electrons. And then you look at fluorine, which is in the 7A group. But then you have to multiply it by 3 because there's 3 in the compound. So you do 5 plus 7 times 3 is 26. Alright, the next thing we'll be looking at is the Lewis structure. So first, we need to remember that we can use 26 valence electrons. So first we look at these lines, and they all represent 2 each. So there's 2, 4, 6 of them. Those are the bonds. So you do 6, you subtract the 6 from the 26, you get 20. So you have 20 valence electrons to fill up. So you fill up all of these octets like this, giving them each 6 more valence electrons. So in total right there should be 18. And then for the last one, so 18 minus 20, you get 2. So for the last 2, you fill nitrogen's octet right here. And that's how you get the Lewis structure. The final thing to look at with NF3 is the 4 electron groups, 3 bonds, and 1 lone pair. So looking at the chart I have here, we find 4, 3, 1, which is right there. So the electron geometry is tetrahedral. Angles between the electron groups is 109.5. The molecular geometry is triangular pyramid something. And the final thing to answer is whether it's polar or non-polar. And it's polar because it does in fact have 1 lone pair.